Right, good morning. So first thing I'm going to do is I'm going to begin with a setting up the SparkView. And so I've called up SparkView. So I'm going to go ahead and start with a manual entry mode. Some of these labs are already predetermined by Pasco and they're already set up for us, but this is a pretty straightforward one and it's a pretty easy to do. So what I'm going to do, start off here, is I'm going to define what X and Y is. Since X is the independent variable, it's the one we control, then I am going to set that for volume, and we're going to set that for syringe volume. So I'm going to go to user entered, and I'm going to create a data set, and it's going to be plunger volume. And my unit of measure is going to be the milliliter. And I am just going to leave it like that. And now that's my X. And then I'm going to come down over here. Let's close that down a minute. And I'm going to set X to be plunger volume. There we go. Now for Y, on the other hand, I have to have my dependent variable. In this case, it's going to be pressure. Pressure is going to be responding to whatever I give as the volume in the syringe. The last thing I want to do is set this for manual entry. I don't want to use periodic because I'm setting the volume for the plunger values. And we're going to start, I think what I'm going to do is start about, let's say 10 milliliters. And then we're going to start at, let's give it 20 and 30 and 40. And I'm going to stop at 50. I could go all the way to 60, but that's not necessary, okay? I think we can do that with 5 data points. Oh, what the heck. Let's go ahead and put 60 in there. Make it an even 6. All right, so those have been manually entered, and what I'm going to do is when I push the start button, it's going to measure pressure for us. All right, so let's go ahead. I'm going to also do this. I don't want my origin way up there. I want to just look at, there we go. I just want to look at the first quadrant, like so. And ideally, obviously, if you have 0 particles, you should have 0 pressure. But take a look here, though. This has air in it already, and there's going to be air right here. So we're never ever going to get to a point where there is 0 particles inside this system. It's just not physically possible. So we're never going to really cross the 0 axis. Now, I haven't quite found out how I can force it through 0. I know in the Vernier software you can force something through 0, but just keep that in mind that this is probably not going to go through 0, and that's okay. It's understandable why. Now, let us start first. I'm going to do this. I'm going to pull all the way back. It is more accurate to measure pushing forward. That's why when you see doctors working, they always pull the syringe back and then they push down to get their dose. It is much more accurate this way, and I'm going to take it all the way down to, make sure you can see that, 10 milliliters. And then I'm going to attach it to my Pasco probe. Now, just to make sure I'm connected here, because I did start a new experiment, there it is. I am connected. That's good. And so what I'm going to do now is I'm just going to gently tighten that down. That is what's called a Luer lock right there. And they can be stripped, so you want to be very, very careful about that. And what I'm going to do, this is going to be kind of difficult. I'm going to push start, and you'll see this green check right here. And what I'm going to do is, Avogadro's law says that it's the number of particles of air, not the volume. So my plunger volume really is going to be 60 milliliters total that I want to use, but the amount of air inside is going to be limited. So what we're saying is if I fix my volume to be 60 milliliters, then as I add more particles, pressure should increase, right? So if I were going to make a prediction, if I had the option for a prediction, then I could draw a line like so. Now, I didn't stop it. I'd have to stop it in order to do the prediction. We can't do the prediction while the experiment's going on. But you can do that for me during the lab. All right, so I've got it at 10 milliliters, and now I'm going to pull it back to 60. Watch pressure as I pull it back to 60. Now, this is really tough. Oh, it's almost creating a vacuum on the inside. The pressure is only 17 kilopascals. That is really low. So I'm going to try this again and see if I can hold it and hit my mouse at the same time, because this is tricky. I'm going to try again, and yeah, it's popping veins in my neck, guys. All right, so there's my 60, and I'm going to try, yeah, there we go. Whew, that was tough. All right, so what I'm going to do, I took it off. I'm going to pull back to 60 or 50. Let's just pull it back to 50. And this time, I'm going to go up to 20. And we're going to stop at 20. And, you know, you have this is called a flange up here. And this, a lot of people do one of two things. They either use the point or they use the edge of the flange. I think the edge of the flange is easier. A lot of students prefer that anyway. It doesn't matter as long as you're consistent. Just be consistent. So I'm going to pull this back now. I've got my mouse set to go so I can click it because it takes a lot of strength to hold this. I'm going to go all the way back to 60 again, trying not to pop it out. Okay, and click. And you can see what's happening here. I went from 18 to 32 kilopascals. So once again, push out. I'm going to bring it back here to 50 or so. And I'm just going to squeeze it down to 30, like that. I'll put that back on there. And then we actually do this lab at our seats because it doesn't require bench space. Pulling it back to 60 again. Remember, we got to keep volume constant. And that raised the pressure up. And one more time, we'll pull back to 40. There we go. 40 milliliters of air in there now. Once again, we're pulling it all the way back to 60. It's getting a little easier to hold, so I can probably hold it with one hand right now. Like so. And click. We're going to do 50. So I'm at 50 right now. Pull it back to 60 and just hold it there. Usually two people do this because it is so difficult to hold that. All right, and I'll pull back just a little bit past 60 and bring it back down. This should be room or atmospheric pressure now because it is a full 60 milliliters, and so we're reading 95.3. In case you haven't noticed, this is Monday. We have snow coming in, so pressure has dropped tremendously. All right, so I've got my line, and I'm going to go ahead and stop collecting data. And there's my first run, and it is a pretty darn good linear fit. And this time, I'm just going to close that out of there so it's hidden. I'm going to go ahead and hit start. And this time, what I'm going to do is I'm going to pull back to about 30 milliliters, about midway here, get a good volume of air. I'm going to attach it directly, and this time I'm not going to take off my syringe. Instead, what I'm going to do is I'm going to push this syringe forward and backward from this midpoint. So here, let's go ahead and get, so we want 10 first. So we're going to push forward to 10, and oh, this is painful. It doesn't want to go to 10. It wants to, I can't get it to 10. I'm going to take it instead to, I think I can hold it at 12. So I'm going to come over here and I'm going to stop this. I'm going to change this to 15. And then we'll do 20, 30. It's just too much. It's too hard, and I don't want to damage my gas pressure sensor. All right, so run 2's out. So let's try run 3. So once again, I'm going to try and push it. 10, 12, 14, and 15, right about there. All right, and then I'll pack it up. And I'm going to push forward to 20. Trust me, this is more resistance than you think it is, or think it would be. Okay, I'm going to come back. I'm going to let it rest at 30, which, not surprisingly, is that atmosphere. I'm going to pull back to 40 now. Come on now, hold still. I'm fighting my dog. And then I'm going to go back to 50. And I'm going to see if I can get 60 in here. I got a big vacuum going on right now. Close enough. Close enough. Actually, that wasn't close enough. We'll just get rid of that data point because that's not good. I have another set of data that we can use that, so we can remove that point. It's actually, no, it's trending in the right way. Okay, so as you can see, this looks a little different. In fact, I can do a linear fit on this. Inverse fit rather, because this is inversely proportional. There we go. Oh, that's a nice fit. That hit every single point. That's actually not bad data, despite how much pain I was in getting it done. But if you take a look at this curve, now keep in mind the real part of this that is the inversely proportional is going to be like right in here, this zone right in there. That's where we can actually get reasonable data. Anything this far up out here or way out here is not going to give us good results because what happens is this bend off that occurs. Now what's happening here is as you get to lower volume like this, you are pushing hard against this sensor, and it's never going to reach a point where you can actually get it to a finite number where you can actually measure the pressure. And same thing goes over here. No matter how far out I take it, it doesn't matter, because as long as there's particles in there, no matter how big the volume is, it's never going to go to zero pressure. It'll approach it, but it will never get there. And that's the limitations of the experiment. We are dealing actually with a real gas, not an ideal gas. An ideal gas is one that has no interactions whatsoever, but that's not true with this real gas. but it's small enough concentration that we can at least see the gas laws in action. And so right there, right that zone right there is where you're going to have any data. So I'm not going to resave this. Actually, I think I will because this is actually pretty darn good. We're going to save as, and what I'm going to do is first cancel that because I want to change this. Rename. Current page, we're going to call this both Avogadro and Boyle's Law. I can't type, sorry guys. Okay, so there's Avogadro and Boyle's Law, and we're going to save that as both gas laws. And what I'm going to do is I'm going to manage the runs here. I'm going to choose a run to delete. It's going to be run 2. Okay, there we go. So now I've got run 1, which is our Avogadro's law, and we've got run 3, which is our Boyle's law. And I think that will probably work for you. Instead of giving you 2 different files, I'm just going to give you this file, and you'll be able to see the data for yourself, and you'll be able to write up your gas law report as far as the report goes. But there you go. There's your data. And it really is, I just really wish you guys could do it. It's not hard. It's fun. You can do it with a partner. But unfortunately, COVID, what can I say? All right, guys, you have a good one, and I will talk to you soon. Bye-bye.